base microcontroller and then add cap touch. You can get as many as 27 with the 8977. And you have A to D and all that other stuff in these parts. Now, when you overlay on that 8-bit and you say if you just want the parts that are preloaded with the code, these would be the equivalent cap touch controllers where we preload the code and they're configured to just be cap touch, not the microcontroller. But if the person wants to revert back and go back to the original microcontroller, they can, and we'll give them the cap touch code. Tony, I'll ask you and Herb for your help on this because what we're going to introduce in the 32-bit families, there'll be RISC parts, RISC-V, which are open source, and then there's ARM, M0. So I'll let you guys say a few words about this.
Yeah, so as Vince said, we branched into both RISC-V and ARM for our 32-bit MCUs. Starting with the 9310 and the 9201 and the RISC-V, and then the ARM offerings are the 9202 and the 9208 with more to come. So RISC-V is an open source instruction set. There's no IP cost, so it's widely available and it helps keep the cost down. But we do also get a lot of requests for an ARM, so a lot of customers have ARM code already. It's easily portable. It's widely accepted. The M series is the microcontroller series of ARM, and that's for embedded applications. It's ideal for your smart sensors, your mixed signals, SOCs. It is optimized for low power and small size. So the M0 is the smallest ARM core. And as you work up the M series, they add, peripherals, deeper pipelines, but all at the cost of size and energy efficiency cost. So we think the M0 is a good place. It's basically the 8-bit MCUs or a 32-bit MCU at an 8-bit price point. Um, Not to be confused with the ARM A series, which is your high-end ARMs. Those are made to run Linux, RTOSes, etc. These are embedded. You can see there's 256K of flash and 16K of RAM. So a
Right.
nice embedded MCU part.
Yeah, people will not run Linux on this as well. We'd like to just make sure you understand it's going to be an RTOS or their own little code, just like they'd run on a little 8-bit. There's quite a bit of memory on these. We can do cap touch on these, and you'll see our offering that I'm going to go into the next page. Herb, did you have anything to add here?
The only thing I wanted to add is another reason for the two product offering is because the RISC-V products, it offers a reduced instruction set. So a lot of people a lot of engineers like to use it because it speeds time to market. The code is simplified. A lot of open source tools and libraries. And you'll find that a lot of engineers on the other side of the equation, they prefer the ARM because there's something called a chemist, which we will be going over later, which includes what's called a Hall library, which is a hardware abstraction layer. So it allows code to be ported from one ARM to another. And so as the performance and requirements change, you can reuse the code easily. So there's advantages to both RISC and ARM, and that's the reason we're introducing these two technologies.
All right. And as we go on here, if you guys have questions, please just drop them in the chat window and we'll address them at the end real quickly to go over all those questions. So to look at what we have for 32-bit offering, there are two parts sampling right now, and that's this CS9310 and CS9201. Now we're offering this in the IS31 and the IS32 version for industrial and automotive. You'll notice we've added in an 8 by 12 LED matrix driver onto this part, the 9310. That's great so that you can run like on a white good application or in an automotive center stack, things like that, or a shifter knob area, you can run a lot of LEDs. And this is one of our flexible matrix LED drivers. And you can drive up to 80 milliamps on each of the 8 channels in the 8x12 matrix. Very low quiescent current when in sleep. And you can do the cap touch on this. We support what we call our Gen 3. That's the latest, greatest cap touch that competes very well with all that Cypress stuff and other people's stuff. We do really good. We can do the active proximity sense. We use that acronym APS, active proximity sense. It's available on this stuff. So you can do the cap touch, LED driver, and have a RISC-V running everything. The parts will come with different sizes of memory, like the 256K or the 64K. And this 9201 does not have an LED driver. We also support LIN bus on all this stuff. You'll see that across here. So when we support the LIN bus, this is a great bridge to, and I'll go into it in a slide or two, to run some of our other parts for LED drive. So it becomes, the processor is an architectural decision that the engineer is going to make. This gets you in early on the discussion to do the processor and the LED drive and show them a lot of integration. There's a couple parts that'll be coming out in Q2 and another one that's just probably after that in Q3. The roadmap of these, just remember our 8-bit, this is existing stuff, and then we have the associated cap touch. There's 2 new parts that are coming very soon, and these are going to have LIN PHYs built into them. So the physical layer of the LIN bus is built in, plus an LDO into that microcontroller for a whole system. 32-bit wise, we have the 2 parts released right now we're sampling. We do have eval boards. Tony and Herb are working to make sure they understand all the tools, and we'll go into that in a little bit as far as what we have to help your engineers lay out the code and get everything going. For applications, this is like an automotive or white good application with the first part, the 9310. That LED driver running a huge matrix can do all kinds of things, 7-segment displays, icons, RGBs. We also have the input on here on the right. This is touch key. You can do gesture sensing. You've seen we could even do liquid level sense. Tony's been helping a lot of customers with level sense and reservoirs. Proximity sensing. We have an onboard buzzer generator. We can drive haptic sensors that make buzzes and vibrations and clicks. There is SPI, I2C, SDIO so that you can run out and get out to your USB and everything else. So this is sampling now. Think about automotive center stacker places in, heck, even trucks, tractors, the many things where you have a lot of buttons and LEDs and you need cap touch in addition. You don't have to run just cap touch. You could use these as membrane switch closures as well. The 9202, this is going to be our first ARM M0 Plus. And we're really looking at that to optimize and run out to UARTs where we can hook up to our CAN PHYs and then run what we call Lumibus to these long strings of LEDs to correct the color. And you guys have heard about these LED drivers like the 3202 in other presentations. But again, we'll have inputs like cap touch and other sensors, buzzers, consoles, all that aggregating in, but then using LIN bus or UARTs to communicate inside a vehicle, run seat controls with GPIO, monitor touch sensors and sliders. So think of those infotainment areas, rear portions of cars where you need to jump panels, smart armrests, steering wheels. Okay? With that, I'm going to hand it over to Tony to go over some of the development tools we'll make available to you and the customer so that you can explain that to them.
Yeah, Vince, if you could back up a slide, I want to point out just a thing or two. As you notice, we like to put LIN and CAN to help, facilitate automotive applications. And also the SPV, the video serial bus, which is a high-speed SPI bus, and those are made to run like a whole bunch of LED drivers that are daisy chained out the UART. So our Lumibus is like a CAN light architecture, so your CAN high, CAN low, and addressing, and you combine that with the DMA access memory. It just makes for a really fast bus that doesn't tie up your processor. I just wanted to point that out quick.
Good point. Good point.
Um, you can go on to the next slide if you want. Okay, so here's a list of our development tools for the 32-bit MCUs. We have the IMSC, which is an intelligent MCU smart configurator. We have our touch key configuration GUI. For the RISC-V, we use VS Code for the editor and the IDE, GCC and GDB for compile and debug. And then for the ARM offerings, we'll have the Kyle MDK, IDE, and compiler. We also have a JDI JTAG debugger, and we have a Lin node configuration tool if you're doing Lin applications and you need some help getting that up and running. So
Just,
the touch key.
I've jumped a slide. Hold on a second. My computer is jumping faster than I am. There you go.
Okay, so the IMSC, it's just a kind of a visual configuration tool, and it's there to help you quickly get your project up and running, and select your processor, and that'll import all the configuration package. Uh, Configure all the peripherals, your system clock, do your pin assignments and pin configuration for your I/O. Also set up your debug, and it can do some code generation, especially for our CapTouch parts. So
Yeah,
let's
this
go
is
on.
important for anybody who's not done much in MCUs. One pin on a part might be able to be configured as an I/O or as an A to D converter or part of the I2C bus or part of a LIN bus or part of something else. But you need to go configure what that pin is going to do in the setup you decide the way you want this processor to work. And so this configuration tool is kind of early on. They set it up and they direct pins where they need to be.
Right, because nearly all the pins are assignable to the peripheral, so you can put the part on your board and then decide later where all the peripherals need to go based on your routing.
Mm-hmm.
The touch key tuner interface. So this lets you plug into your part, whether we have a similar GUI for all of our parts that have touch key capability. So the standalone touch key parts, along with all of our MCUs, you can plug into your board and run this GUI. It will load a little program onto the part and allow you to do your calibration and configuration all in circuit for your application. It'll save that configuration file and the calibration values. It'll save that off as a binary, and then you can drop that into your application it'll give you the parameter file. So a C file, a header file, and a binary, a library. And that's just used to jumpstart your touchkey application. Just makes it all quick and simple. And this will be available for both ARM, RISC, and 8-bit. You can go ahead, Vince. Thanks. And we also introduced our JTAG debugger. So JTAG, it's an industry standard for testing debugged circuit boards, processors, and this is used for programming your flash and, of course, the debug.
Yeah, so
And shown here.
what we're trying to paint a picture of is
Right.
we have the early on tools, we have the other in the middle tools, and then there's other things to get the customer on down the road.
And shown here is the 9310 evaluation kit board. So you can see it has big matrix of LEDs and touch keys and a little proximity sense pad. And now I'll pass it to Herb.
Hello, everyone. My name is Herb Chun. I'm a MCU product manager based in Milpitas, California. So what you have heard so far is some of our 8-bit MCU plus touch controller product offering. You've also been introduced to two of our newest 32-bit microprocessors, which includes the 9310, which is RISC-V base, and the 9202, which is ARM Cortex M0 Plus base. You've also been introduced to some of our simulation and configuration tools. But what I'm going to be introducing in the next couple of slides is what does the software landscape look like at the system level? And more importantly, what if your customer is not using the same tools that we're using? Does that mean your project is at a halt? I'm also going to be introducing to you at the component level what the software landscape looks like and how does Lumissil stack up. I'm also going to be going over again once more as a summary the 9310 and also include the 9202 software packages since that wasn't introduced, but I will introduce that to you. And lastly, what I'm going to be doing is I'm going to be going over a scenario with you for which you might, when you approach your customer, what you might expect. Okay? So beginning at the system level, the software landscape, you can see just from this visual is very vast. There's all kinds of applications. There's all various types of operating systems. There's all different types of coding languages that might be used. And this is only for the RISC-V, not talking about the ARM. Okay, next slide, please. Okay, at the competitive software landscape level, how does Lumissil stack up against other semiconductor manufacturers? Well, I did a survey, and again, Lumissil with the 9310 is using VS Code, and you've been introduced to the JTAG. Well, if you look at Renaissance, they're using Eclipse and also IAR and another version of JTAG called Seeger. Infineon is using a version of Eclipse and DAP. And Microchip is using a version of Microsoft Visual Studio and for their debugger, AVR1. So you can see essentially is that all of the semis offer a dev tool, which is basically IDE based in some flavor or another. And they're using a debugger, whether it's JTAG, DAP, or AVR1. So what is the difference between JTAG, DAP, and AVR1? Essentially, they're all the same. JTAG is essentially a firmware loader and a hardware debugger that you can go into the chip itself and debug versus our 8051, which uses what's called an ISP. An ISP, it can only load firmware, it cannot do debugging. So software has to be debugged at the software level. Another difference between JTAG, DAP, and AVR is fundamentally its speed. JTAG operates at very low bandwidth, whereas DAP operates at mid-range and AVR is fast. So essentially, from the functional point of view, they're all the same. They just load programs and they can offer debugging at the hardware level internal to the chip, whereas an ISP, it can only load firmware. So at the semiconductor component level, essentially not that much difference. Okay, next slide, please.
Okay. Acronym wise, guys, everyone on the phone, IDE, that 3-letter acronym means Integrated Design Environment. So after we've configured the part to tell it what pins are what, then you need to go into a design environment where you write code and compile and create the code that can be loaded onto the part. Debuggers such as these JTAG debuggers are just used to go in and set stop points, watch points, debug the code to make sure it's working. Hope that all makes sense. We do talk in a lot of acronyms. just remember integrated design environment. This is where most of the work is being done to get the code written.
Okay, just touching upon the tools once again. You've been introduced to the 9310, which is a RISC-V based. It's using VS Code on Windows, although it's using Linux, GCC, and GDB tools, which are traditional Linux, a Linux compiler and debugger, but it's porting over to the Windows side using through a Windows subsystem. And for the burning tools, we're using a GDI, which is basically a version of JTAG. And as an add-on package, we're including Hall codes, which essentially is an hardware abstraction layer. And what this allows you to do is if your RISC-V chip changes to a different version, the abstraction layer basically abstracts the hardware from the software, meaning that you can reuse the code.
And that can also work to our benefit, everyone. If they've already been using a RISC-V, if this exists on what they've been using, they could kind of port to us. Isn't that right?
That is correct, yes.
Yeah.
Okay, for the 9202, it's ARM-based part. It's using ARM-based IDE compiler and debugger, which is QMDK. MDK stands for Microcontroller Development Kit. It's a standard ARM product. And for the burning tool, it's an ARM emulator. And for the add-on package, it's using Kimis. And if you look at the figure on the bottom left, Kimis is basically an interface, which is an all-encompassing interface, which also includes Hall. And again, this is the main selling point for ARM products is that the code is abstracted from the hardware, meaning that if they were to use different ARM versions, the code can be ported to different ARM-based microcontrollers. Okay, next slide, please. So here's a design scenario. Let's say you go to your customer and they describe that they are designing a mid to large project. What you're going to find for these kind of projects, probably more than 90% of the time, it's either going to be Windows-based or Linux-based. Well, for this design example, let's say they're using the 9310, which is RISC-V based, and we're offering it on VS Code. Well, if they're on Windows, all good. They can continue their coding on VS Code, no issue. But what happens if they're saying, okay, our platform is going to be on Linux? Is that a problem? Well, no. The reason is because what they can do is they can configure our part through the VS Code using our configuration tools and then port over that code into Ubuntu. And again, we're using GCC and GDB as the simulator for VS Code so they can readily simulate in Linux. Not a problem. So for mid to large projects, which represents the bulk of the opportunities out there, no issue at all. The only thing that we want to highlight is if they're running very small projects where there's no operating system, they're not using Linux, they're not using Windows, then what do you do? And they mentioned to you that they're going to be using something called RTOS, which stands for Real-Time Operating System, which essentially means no operating system. So most likely they're going to be using something called FreeRTOS. FreeRTOS, all it is a low-level, bare metal scheduler, which you can prioritize tasks or execute tasks at a very low level, one by one, in a specific sort of manner. So in these cases, do we want to discard that opportunity because most of our design tools, etc., are configured for Windows or Linux? No, what we want to do is if you see this kind of opportunity and you think it's significant, what we like to do in those cases is contact us. Okay, so for that, what I've described to you is the software landscape, our competitive landscape for at the component level. Also, I gave you a summary of the types of tools that's used in 9310 and 9202, and also a design scenario. With that, I'll hand it back over to Vince.
Yeah, this is all we have today. We kept it to a half hour, but I would like to open up the floor if you guys want to
Yeah, we got a
unmute.
few questions here. So the first question is, Herb, why don't you describe why somebody might choose RISC-V versus an ARM core?
Yes, of course. So again, it has to do with preference, and also it also has to do with time to market. So for ARM devices, the thought process is that if a project starts on ARM, and let's say that the product gains more features, and they want to use a they want to have more processing power on their platform, they might migrate up. And the thought is that it's easy to migrate from an ARM to another ARM processor. So a lot of people, if they start on ARM, they're going to continue with that. RISC, on the other hand, because of its reduced instruction set, it allows you to program faster, easier. There's a lot of open source code that's freely available. And so some engineers prefer that. So there's two schools of thought. It depends really on what they start with and what the product dictates. And this will tell them one way or another to take a RISC processor versus an ARM. And that's why we are offering both.
Great. Another question we had is on the RGB calibration for the CS9310. Can the files be held at the controller itself, the calibration files?
A question on that question is like, I guess they're talking about if they were to use like our external parts like 3202 and all these other things are 3183A. The calibration files are just, I mean, those things are like shifted in.
Yeah, I mean, you can store anything in the flash of the MCU. I think the distinction is a lot of our LED drivers do not have they're not an MCU, but they have the additional ability to store some calibration data. So like the 3183 or something. So with an MCU, yeah, you could store
Okay, well, let's not
any.
mistake the 9310 LEDs with 3183 type of platform. There's no calibration files that you normally store for LEDs for 9310, because all you're trying to do is like displays and stuff that require single color, little bit of color mixing, but nobody's really critical about accurate color. So there's no calibration files, but there should be calibration for touch control, and that'll be stored in the MCU flash.
Okay, and then the dev tools, as somebody asked, are the development tools free of charge? Yes, they are.
The software is anyways.
Yeah. And when you get to the Kyle compiler on the ARM, correct me if I'm wrong here, Tony and Herb, but we have a floating license that we can loan to the customer if they don't have a Kyle compiler and debug. Is that right?
That's true for our 8-bit tools. I am not positive about that on the 32-bit.
Okay, that was something we'll have to check into. Somebody asked if we are on the S5 list yet for General Motors with this part. No, we are not, but we've highlighted it to General Motors. And the S5 list is one that GM, when they go to tier ones, if you're not on this quote S5 list, they don't want the tier one to use you, but we're working to get ourselves on that list with these parts. It would help. So anybody that deals with a tier one that feeds back to GM or Ford, let us know that your tier one's considering it. And then we can go work the other angle and let Ford, GM, these other guys know, hey, so and so, Continental, whatever, they're wanting to use this part. You need to look into it more. So we need that communication. Lynn, do you see any other questions here that need addressed?
Yeah, we had a couple questions kind of embedded from Occam here. So the first one was on 9310 without an LED driver. Again, this is the first product we have, and as I mentioned at the very beginning, we will be introducing more products, so there will be some scalability here. Herb, you want to comment on that?
No, not at this time.
Okay. And then automotive lead projects with a 9202. You want to talk about that, Herb?
What was the question again? Could you clarify, please?
Automotive lead projects for the 9202. In other words, what are we targeting on the 9202?
Well, okay, if you look at that diagram, okay, can you flip to the diagram? There you go. So if you look at this diagram, this is an all-encompassing part where it has full features, touch control, GPIO. It also contains what we call Lumibus. So this is really a general purpose part that can be used for all different kind of applications, including door handles, console applications, and also if you want to drive long strings of LEDs, you can facilitate it through Lumibus. So really this device here is our all-encompassing, all full feature product. It also contains 4 times as much more memory than any of our 8-bit MCUs ever produced. So this device, we consider it a general purpose microcontroller that can serve all of the various applications shown.
So to get back to Akim's question, the 9202 is essentially it's like the 9310 swapping out the built-in LED driver for the high-speed buses to drive LEDs. So Lumibus, smart video bus, those are all high-speed intended for driving LED controllers.
Yeah, it looks like we also have a PWM controller that's a little more advanced on that 9201 to run PWMs that could be motors, anything else, you know.
So yeah, with that, again, as I mentioned at the very beginning, so the 32-bit family, we've listened to you, and we understand that customers want the 32-bit parts, so that's what we've come out with them. What we're asking for your help now is to start getting these parts in front of customers. As we get more engagement with customers, that's what's going to drive the roadmaps going forward as well. So get us in front of the customers. We need opportunities. Hopefully, we're giving you enough information here that you can get to the first and second level of questions. But we are here to help. We've got Tony will help anybody. Herb will help anybody. Of course, we got Mike and Vince, local help as well. So just go ahead and reach out to us. We'll get on the phone with any of your customers, face to face, whatever it takes. So we're here to help. And with that, I think we're closed. Any other comments or questions? We'll open it up. Just unmute yourself and ask a question. Otherwise, we'll close it up. Oh,
ballpark pricing. Somebody's asking 100K. I have not seen it on our price list yet.
I'm not sure, Rich, which part you're talking about.
I think, yeah, so somebody asked a question about pricing. I know that on our 8-bit 100K, the 50 cent range has been easy to hit.
Yeah.
On these, the 9310 with LED driver, Vin, do you have any comments? What you think that range is with all LED drivers and everything on a 9310?
Yeah, it's about less than $1.
Perfect.
But maybe more than 90 cents. More
Between
than
80 to $1.
Okay.
Yeah.
So at 100K with the LED driver, we'd like you guys to try to get as much as you can because there's a lot of integration there. What about the part where it's just Lumibus, the 9201, and we remove the LED driver? Is it going to be slightly less than
Yeah, it'll be less than the 9310, of course. Yeah,
but not 8-bit price?
not the 8-bit price. Yeah, it's between 50 to 80 cents. Depends on memory.
So it sounds like, that, and this was the industrial and the automotive. The difference in price on industrial to automotive is probably not too different.
It's about 5 to 10%.
5%. So 5 cents at a dollar. But you'll probably find your best applications for this in automotive where they need the AEC-Q 100.
There's
Anything
another
else?
question about, oh, I'm sorry. There's another question about OEM engagement. So the answer is yes, we have brought this in front of a couple OEMs. We mentioned GM earlier, so we're working on the S5 list there. And with all the OEMs, we have to get approval from a MCU standpoint. So we're working on that right now. But as you're again bringing it forward, bring us the opportunities. We'll work with the OEMs. We've got the contacts in place for most of them to get that process started and show them the value add that we bring. And I think that's it. So with that, again, I want to thank everybody. We'll be doing more of these trainings. It's very difficult to get everything done in 1 hour, and some of the parts are getting complicated. So we'll be doing some extra training beyond the normal hour that we do every month to do like this. If you have any comments or questions or ways, suggestions to make this better, let us know, and we'll try to incorporate that for next time. Thanks a lot.
Thank you.
Thank you.
Thanks, everybody.
Thanks, everyone. Have a great day.
Thank you.